Hey guys, so I'm from ChronoLogic. We're working on the Ethereum Alarm Clock project. This is a project that is trying to fulfill a foundational use case on Ethereum. So what it is a smart contract protocol that attempts to create a way to schedule transactions and have those transactions executed at the preset time. And we are trying to do this on the blockchain, have it trustless, decentralized, and all of those good things we like about the blockchain. So the project was originally started by Piper Merriam in 2015. And back then he had gotten it working, and he works on a bunch of different stuff. So unfortunately, the alarm clock kind of fell into a state of not working for a little while. So when we came around toward the end of 2017, we picked it back up and we ported it over to use truffle tests, and we got it working again. And right now we have it deployed on the COVID test network, and we're putting it through a security audit to deploy onto the mainnet, hopefully soon, hopefully within the next month. So just a piece of history, Piper Merriam giving a talk at DevCon 1 on the alarm clock. So why do we need this? So scheduling transactions is something that people are used to. The developers especially are used to being able to set a cron job. But with blockchains and Ethereum, there's no way to mimic this functionality. Developers can do this locally, but we want to be able to mimic this on a global decentralized level and have trustless guarantees. So going a little bit deeper, the reason why we need to set up a protocol to handle scheduling transactions is because of the two types of accounts we have on Ethereum. So we have users which control the private keys, and these are the accounts that can actually execute transactions, can actually sign transactions and publish them to the blockchain. And on the other hand, we have the smart contracts, which can do things like hold funds and can hold logic that when they're executed, they can do certain things, but they can't actually execute themselves. So what we want to accomplish is a way to make these smart contracts execute themselves. So there's tons of use cases for the alarm clock, from buying tokens at an ICO to any kind of routine payments. You can schedule a smart contract to send a transaction to itself every month. We've built tools to allow developers to integrate this into their dApps, as well as developers can do this from smart contracts as well. We're working on wallet integrations. ENS reveals, so the Ethereum name system, right now requires a two-step process where you commit for a name, and then you have to come back a few days later and reveal that commit. And if you fail to reveal this commit, you lose that name. So what happens a lot of the time is people will forget to come back in a few days. With the alarm clock, you can just set that second transaction to be executed in a few days, and when you commit, you schedule that one as well. And lastly, you can run a time node, which is the other end of the alarm clock protocol, and these are the agents which are executing all of these scheduled transactions. So I'll go into a deep dive a little bit of how the architecture works. So it's a smart contract protocol. The smart contract can be divided into 4 major groups. We have the schedulers, which are the API that the users talk to. These talk to the lower level request factory contracts. And we are actually taking this out, but we had a request tracker which kept track of all these transactions. We're moving now to using event logs instead, so we don't need to keep all of that state. And then we have the transaction request, which is each scheduled transaction is actually its own smart contract on the blockchain. This is just a way to visualize it from how the user will see it, kind of like the iceberg. The scheduler is the tip of the iceberg in this situation. And here is the dependency chart for all the smart contracts. This is how they're talking to each other on the protocol. So going into the flow of how scheduling on the alarm clock actually works, we have a user that knows when they want to send a transaction, and they send these parameters to the Ethereum Alarm Clock contracts. This creates a new scheduled transaction contract or a transaction request. And then we have the time nodes watching the blockchain for each of these new transaction requests. And we'll then execute those transactions at the predefined time and get paid a bounty payout for doing that. So there's 2 variants for the scheduler. You can schedule with either the block number or the timestamp. Here's the interface for that. I just want to point out that when you're scheduling, these are the parameters that you actually send to it. So the to address or the destination for that transaction, you put in the call data. So if you want to execute a certain function on a smart contract, you can send the call data here. And then we have the normal parameters for an Ethereum transaction, which is the gas you're sending with the transaction, the value or the amount of ether. So this one is the window size, so the amount of time that the transaction has to be executed. Because of the way the Ethereum network works, we can't guarantee an exact block, but we can guarantee a set window of about a minimum of 5 blocks. But you can set this to be as large as you'd like. The window start is the time when the execution window begins. The gas price, so this is a way to prioritize your transaction in the transaction pool. And then a couple things that are special to the alarm clock protocol, which is the fee and the bounty. The fee is a way for developers to incentivize integrating the alarm clock into their protocol. So this is something similar to like an affiliate payout that, for example, Shapeshift uses. If you have their widget on your website, they give you a small amount from every transaction that goes through there. In the same way, any website that integrates the alarm clock can take a small amount from every transaction. And the bounty is what is incentivizing each of the time nodes to execute a transaction. Oops. Okay. So each transaction is its own smart contract, the transaction request. I won't go too much into this. I'll just jump to here. So when the transaction is scheduled, it has a window to be executed. And you can see this at the far end. But before the actual execution window begins, there's a period of time where it can be executed by a time node that has claimed it. And this claim mechanism happens essentially right when the transaction request is scheduled, there's a payment that, depending on when the transaction is claimed, the payment is dynamic, so it either goes up or down, and there's a certain time where it becomes profitable to claim that transaction. And so on the other end, we have the time nodes which execute this transaction. So time nodes are off-chain clients. They're written in JavaScript. How they work is they're open source. Anyone can just download it from GitHub, have it start running on their computers, and the client will start scanning the blockchain for all of these new transaction requests and executing them if they're set to be executed. This is how we guarantee the trustless nature of the alarm clock. Because it's essentially free to run one of these, and it will likely be profitable if there's transactions to be scheduled. We see that a lot of people will likely want to run a time node, and the more people that run a time node, the more nodes we have that execute transactions, and the more decentralized this entire environment will be. So the incentive is the bounty that's scheduled with every transaction. It's a small amount of ether that's sent along with the scheduled transaction, and this is what gets sent to the time node. It's set by the user schedulings, and it's a dynamic, so it can be high or low. Until there's a lot of these being scheduled, most likely they'll be setting the bounty at a minimum variable. But when there's a lot of transactions, we might see the bounty being raised higher. For the same reason you might see the transaction fees going higher on Bitcoin. And then I'll just talk a little bit about the client tools that we've written. So these are just JavaScript libraries that make it really easy for developers to get started working with the alarm clock. There's three different packages. We have a command line tool. So this is a way to run the time node. It's also a way to schedule transactions. We have the lower level client libraries and the lib library. These are just, so the client are the pieces that make up the time node. If you want to write your own time node, this might be interesting to you. The lib is a lower level library to interact with the contracts. And this is the way it works. We designed it to be an extension on the Web3 library, which if you've done any Ethereum development, you're very familiar with that. But you just instantiate the EAC object, and you basically have the contracts available for you from there. And then we've also been working on a dApp. So the client, the command line client is cool, but we can't expect everyone to be a developer and to know how to run a command line client. So we've also been building all this functionality into a nice looking front end. And I'll just walk you through on how this looks. So this is the scheduling page. You can, of course, pick the time zone. You pick the date, and then you can specify the execution window. You enter in the parameters I went over before, the to address, gas amount, value, and the gas price. We've put the call data as an advanced feature. And then specify the bounty, and this is all you need to schedule a transaction. It'll ask you to confirm, and then we've integrated with MetaMask. So the MetaMask window pops up. You submit that. Of course, wait for the transaction to be mined. And then you get the information page. So we also have a transaction scanner. So this is a way to explore transactions which have been scheduled to see what state they're in, whether they've been executed or claimed. you can see this one's been canceled. So we also have a time node that runs in your browser. To test it, you can get some test tokens from our faucet and then just sign a transaction saying you have those tokens in your wallet. So that's what's going on here. And then you're dropped into a dashboard and you just click start. You leave this window open and now your browser is executing transactions. So here's what the logs look like. They're pretty raw, but this is just going through discovering transactions which are set to be executed and trying to claim one of them. And we're really excited to announce that we're partnering with MyCrypto to bring the alarm clock directly into the send page. So we're preparing a pull request right now, and we're pretty much done with that. And we're putting it into the next beta of MyCrypto. So they have two release channels. They have the stable one and the beta one. Will likely be in the next beta release channel. And then we're working on improvements as well. We're going into new mechanisms. We want to use IPFS for the storage. As I was saying before about the transaction scanner, we want to bring off as much as we can to events and have a stateless protocol. We're also working on different kinds of scheduling, so not just time, but conditions as well. And we want to come up with a new claiming mechanism because the one we have now is not very ideal. So if you want to see our new experiments, you can check out our GitHub repository at ChronoLogic./EACv2. And this is kind of how we are designing the next protocol to look. So we're using IPFS natively because we're already running the clients for time nodes. We're kind of just tacking IPFS onto that, and we're not storing anything, or we're storing very little now, and we're releasing everything else as an event. And so if you have any questions about working with the alarm clock, feel free to talk to me, and I think we're open for questions.
That's fantastic. Give us a round of applause. Right, any questions? Worthy of the speaker, over here. I'm sure this is always worthy. Here you go.
Hi. Great work, and it's a continuation. Maybe you mentioned that I came in. It's a continuation of what Piper Merriam started back in the day. But I don't understand the business model. I mean, the only thing I can see is altruism. What's in it for you?
So originally ChronoLogic partnered with the alarm clock to just get it working again without so much of a business model. Right now we're looking at possibly with a claim mechanism using our token in a kind of staking way. So time nodes will use our token to stake, and then if they fail to execute transactions, they might lose this stake. So we're looking into some things with our token. It already ICO'd last year. So that's right now what we're looking at as a business model. Besides that, integrations as well.
Okay, maybe follow up just quickly. What prevents someone from copying the whole system because everything is open source and removing the staking?
Can you just repeat the question?
Yeah, so the question is because the protocol is open source, what's preventing anyone from copying it and removing the staking? And the answer is nothing. So we're kind of hoping on the network effect might lead to people using our version of the protocol, or hopefully whatever mechanism we come up with the staking being an optimal mechanism. But because it's open source, anyone can pull that code down from GitHub and make any changes that they'd like.
It seems to me like the staking is also necessary in terms of an incentive. So
so the staking is because of a problem we have with the claiming mechanism. So what we have right now is time nodes all racing to claim a transaction, and the majority of these transactions getting reverted, which is costing the time node a small amount of gas, but still we want to eliminate any cost on the time node and make it purely profitable to be running these. Otherwise, we can't expect people to run them. So the staking would be a solution to this core problem that we have.
All right, great answer. We have another question here.
Thanks for the talk. You showed a transaction that had been cancelled. Is that after the transaction had been broadcast?
Yeah, so I know I went through that kind of quickly, but what was going on there was the user had scheduled that transaction and for whatever reason decided that this was the wrong transaction to schedule, and they canceled it. So yes, that transaction was broadcast to the chain, and what happened was a smart contract was deployed. So when they canceled it, they just sent a cancel transaction. That smart contract turned into the cancel state, and the money was sent back to the owner.
Good answer.
Thank you. Is there going to be a reporting module with it as well?
Sorry, I didn't catch that.
A reporting module. Reporting system.
Reporting like how?
Like having the insights in your data.
Oh, okay. So yes, we have right now a very primitive way just to keep track of how many time nodes are being ran on the network. We're not doing any kind of analytics beyond that. It was really just something that we put in so we could put the number on our front end, and so we knew how many nodes were being ran. But besides that, we're not doing any kind of analytics.
Okay, so I think we have time for one more question. Let's make this a good one. Anyone? Hands up. I'm surprised. I was expecting more from you guys. Come on. Well, I think it's a fantastic project. I think it's really a critical module in building applications in Ethereum. So I just want to say I love what you're doing here, and it's a service to humanity, as they say. So,
Cool. Thank you.
all right, let's give this man a grand applause here.